Hello, this is Mrs. Nearing, and we're going to go over some more of the problems from the neutralization and titration practice. This is page 22. We went over some of these in an earlier video. So first topic here is balancing equations. So these are all neutralization reactions, but really there's nothing new here. This is balancing, which we did back in Unit 4, if you want to go back and review those. Some tips that can be helpful for balancing this type of reaction. One is to remember our strategy where we make a T-chart, like I am showing up here in problem number 1, and tally. So first step, make a T-chart, count how many of each thing you have on each side. Like I've got 2 hydrogens on the left, I've got 1 hydrogen on the right. When you're doing this, tip number 2, it is helpful to treat your polyatomic ions as one thing. So for example, in this reaction number 1, I counted my SO4s, my sulfates, as a unit. So instead of saying I have 1 sulfur and 4 oxygens, I just said I have 1 SO4. And on the right, I said I have 3 SO4s. So when there's a parentheses, that number outside tells you how many of the thing inside the parentheses you have. So that's tip number 2. Tip number 3 that is specific for this type of reaction is it can be helpful to think of H2O, water, as hydrogen hydroxide. So think of H2O as being made up of 1 hydrogen, 1 hydroxide. So notice in this reaction number 1 here, I counted my waters as 1 hydrogen, 1 hydroxide. That helped here because then I could say over on the left I've got 6 hydroxides and over here I've got 6 hydroxides. So let's go through problems 3 and 4 to practice these tips here. So step 1, I'm going to do my T-chart and I'm going to tally. So I'm going to say, what do I have? I've got irons, I've got hydroxides, I've got hydrogens, I've got chlorines, okay? And I'm going to look on the left. I've got 1 iron, I've got 3 hydroxides, I've got 1 hydrogen, I've got 1 chlorine. Over here on the right, I've got 1 iron. Remember, I'm going to think of water as being HOH, so I've got 1 hydrogen and 1 hydroxide, and then my Cl has a 3 by it, so I've got 3 chlorines. So it looks like my chlorines are not balanced, so let's start there. So I'm going to put a 3 out here in front of my HCl. That's going to give me 3 hydrogens and 3 chlorines. Notice when I'm balancing, I can only change the coefficient. I can't come along and say, oh, I'm going to put a 3 right here, because this would change what the molecule is. So I can't change the coefficient. Sorry, I can't change the subscript, only the coefficient. All right, so that balances my chlorines, but now my OHs and my H's are not balanced. So let's go try and balance those. Now I'm thinking of water as being made of HOH. So to get 3 OHs, I need to put a 3 out in front. So that gives me 3 OHs. It also gives me 3 H's. Yay, I am balanced. All right, let's try problem number 4. I'm going to make my T-chart, hydrogen, CO3, potassium, OH. On the left, I've got 2 hydrogens, 1 carbonate, 1 potassium, 1 hydroxide. Remember, I'm thinking of water as HOH. So on the right, I have 1 H, I have 1 OH, I've got 2 potassiums, I've got 1 carbonate. Okay, let's balance. Let's start with the potassiums. Let's do that first. So I'm going to put a 2 here. That will give me 2 Ks on the left. It will also give me 2 OHs. So now let's balance out our OHs. If I put a 2 over here in front of our HOH, that gives me 2 OHs. It also gives me 2 H's, and now I am balanced. Vocabulary, acid, base, and salt. Let's go through, let's highlight my acids in yellow. So my acids are the ones that start with hydrogen. Those are my hydrogen givers. My bases are the ones that can contribute hydroxides, and my salts, whoops, let me change color there. My salts are the things that are made which are not water. Okay, let's scroll down to the next type. In this type problem, we are going to predict the products and balance. So some tips here. This is what we call a double displacement reaction, in which your the first elements, you've got 2 compounds, and the first elements in each of those compounds switch places with each other, forming 2 new partners. So we basically switch partners here. One of the products is always going to be water. And the other product is called a salt. And to figure out the formula of that salt, we're going to use the crisscross method to determine subscripts. So for example, as seen here, if I were to put together aluminum and oxygen, I would say, okay, what's the charge of aluminum? It's +3. Oxygen has a -2 charge. And I'm going to do a little crisscross here. And the correct formula of aluminum oxide is Al2O3. The reason why that is because that gives you 6 positive charges and 6 negative charges. So we're going to use the crisscross method to figure out the subscripts there. Okay, so let's try a problem. Let's look at problem number 7. So the magnesium and hydrogen are going to switch places. The H is going to go with the OH, that is H2O. Okay, and then the magnesium is going to go with the fluorine. Magnesium, if you look on the periodic table, has a charge of +2. Fluorine has a charge of -1. So I'm going to do my crisscross method here, and my formula is going to be Mg1F2. There we go. So that is my salt, and I'm going to go back and I'm going to scribble out the charges, okay, afterwards. All right, and then we need to make my, T-chart to balance things out. So you can count your magnesiums, hydroxides, hydrogens, and fluorines. I've got 1 magnesium on each side. I've got 2 hydroxides on the left and only 1 on the right. I've got 1 hydrogen over here, 1 hydrogen over here, 1 fluorine over here, 2 fluorines over here. So let's balance out my fluorines. I'm going to put a 2 right here. That gives me 2 hydrogens, 2 fluorines. And now I need to balance out my H's and OH's. So I'm going to put a 2 right here. That gives me 2 H's, 2 OH's. And now I am all balanced. Okay, let's try this again for problem number 8. We're going to switch places here. NH4 and H plus are going to switch places. It will be helpful to know that NH4 has a +1 charge. Okay, let's write down all the charges here. Hydroxide has a -1 charge. Carbonate has a -2 charge. You will be given the formulas and charges of the polyatomic ions, so don't worry about memorizing this. Okay, so we're going to switch places. So the NH4 is going to go with the CO3, and then the H is going to go with the OH. So this is going to be water. So let's rewrite it like this. It's okay to leave it as HOH if you want to. And then with the other compound, we want to look at the charges and use the crisscross method to figure out the subscripts. So we just said over here, NH4 has a +1 charge. CO3 has a -2 charge. So you're going to do the crisscross method here, and this 2 is going to go down here. And then the 1 we just typically don't write. So this is our formula right here, is NH4 2 CO3. Then we need to go through and we need to balance it. When we end up balancing it, we end up needing a 2 here and a 2 over here, and then we're balanced. Okay, so now let's scroll down to, let's look at problem 10 real quick too. So 10, you switch places, okay, and the H goes with the OH as always, and then K goes with BR. K has a +1 charge, BR has a -1 charge. Oh look, the charges are already equal. When we do the crisscross, we just end up with K1, BR, 1, and we typically just don't write the 1. So that's just, there we go. We're just done. That was easy. All right, so let's scroll on some more and let's look at, if we look at problems 13 and 14, some neutralization 1. So this is a calculation where we're trying to figure out what the molarity of our acid is, and we know how much base it takes to neutralize our acid. So step 1, we want to try and figure out the moles of the thing that we added. So we know that molarity is moles per liter, so we can find moles by taking molarity times liters. So 0.5 molar times 0.04 liters is our moles here.
The cards